Alright, continuing on with the placement of components, and in this video I'm going to be using the interactive HTML BOM plugin. Unfortunately, I wasn't able to make this plugin work in KiCad for myself because I have some issue with VX Python, so I cannot actually run any plugins. First I thought it was something with the teardrops plugin, but it's the same issue with all of the plugins, and I haven't figured out how to solve this problem yet. But fortunately, the plugin was usable from command line, so I generated this HTML BOM, and I think this looks awesome. I have placed a few components here, but it would be nice, I think, to actually move this list probably to here. However, I have a few components that, for example, here, this resistor is missing because I dropped it and I don't know where it is. So I want to be able to mark something as half placed, which I don't think I can do here. There is sourced. Maybe I could use sourced actually. I wonder if I can save this. Yeah, so I can copy it to clipboard, and then I can probably just paste it into OpenOffice Calc. Okay, we could. I guess I'll just do it like this. So let's see. We can sort it by value, and I picked the top part, the top layer, and let's see. And I'll probably use a combination of this file and the interactive BOM plugin. So let's see what would be the next step here. All right, let's see what next. What do we have here? This is a fuse. This is a fuse in a holder. I just find my gloves. I wonder how I can combine this. Let's see. Maybe like this. And then, let's see, and I could actually look it up by, right, so I can make this always on top, and then I should be able to look up the fuse. So this would be, I think this is the main fuse. This is a fuse in a fuse holder. But what is the number here? 0154. Nope. Right. we don't have numbers here. Let's see what we can find. Fuse. Right, to be the fuse F1. And we can see where the fuse is going to go here. So that's where we're going to place it. This is awesome. Very good tool. Thanks, Damien, for the tip. Okay, so the fuse goes here. Come on. Okay, the fuse is stuck. And it's actually not an issue that the solder paste gets dry, because there is enough solder paste to be able to press the component against the solder paste so that it sticks to the solder paste. When I was doing this without a stencil, I had the problem that it was very hard to apply a good amount of solder paste to the pads, because it doesn't naturally stick to the pads. It needs to be pressed against the pads to stick. So without a stencil, it was hard to have enough solder paste so that components could be pressed into the solder paste. But with a stencil, it works really well. Next is Schottky diode, 100 volts, CDVC. This would be the 5 amp diode. Okay, we can mark that one as placed, and we can go to 5A. No? Maybe 5A like this. No? Let's search for D. Right. These two. No. This diode is hard to grab. Okay. Perfect. 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 Actually, this tool, HTML Interactive BOM, it's kind of the tool that I've been looking for as alternative to what I've seen Louis Rossmann use for his MacBook repairs, where he uses a board view tool, and I downloaded the board view tool, but I couldn't figure out how to export the board so that that tool would be able to read it. So I never actually made it work, but this is a really good replacement for a tool like that. So it's very nice. I have 2 diodes left. How many is it? Yeah, it's 2 on every board, so I shouldn't have any of them left. remaining ones. Next is 600 volts ESD diode. No, 600 watts 12 volt ESD diode. Let's make this one placed. SMBJ D14. D14. D14 will go there. And it sticks perfectly. Very nice. Perfect. Very nice. Perfect. Next is 270 ohm resistors. Let's see, this one's placed, and 270. Let's see, got quite a few of them. Time to place all of them. Can I keep this piece of tape on the table without having it bounce and throw all of the resistors out? Let's see. No! Bounced. Okay. The resistors are saved. Okay, so starting out on, let's see. So one thing that's a little bit hard to like, I can't really see which one is which. So I have to. So let's see. I'm gonna start with R70. You can see where R70 is going. And next I'll take, I suppose that will be R72. Yep. So basically I'm kind of cross-referencing against the list based on what I see on the board. No, there is another one. Another one is missing. Why did it have to bounce? Where is the other resistor? Oh, there it is. It's on my mouse pad. Let's see. It's a little bit fiddly to work with 402 components, I have to admit. Because, like, simple actions like turning a component around can be a little bit challenging. This is a capacitor, actually. This is actually a capacitor. Okay, where is the resistor? Okay, so this would be a missing resistor. Or actually, no, it was there. It was there. it was just laying on the side, so I didn't see it. It was inside the pod, but laying on the side. Okay, so there is a third one over there. I guess it's like R71, which is the only resistor there, so it has to be R71. And moving on, like just releasing the tape can shoot the resistor across the table, so you have to be very careful not to lose a bunch of resistors this way. So where is the next? We have two of them over there, so two of them are right here, and that would be R155 and 49, I think. We have 55 and we don't have 49, so it's probably, could it be R152? Yeah, 52 and 55. So 52 and 55. The tiniest vibration on the table makes the resistors jump. Actually, I'm gonna place R70 on all of the boards so that I don't forget where they are. Okay, this was not a good idea. It's much better to just unpack the tape. Okay, that's what I'm gonna do next after I'm done with the ones that are laying here on my table. Much better to unpack the tape into my little box, and then take all the resistors from the box and place them, instead of unpacking the tape as I go. So it's way too easy to shoot them across the table this way. Okay. Now the resistor is resisting arrest. The resistor doesn't want to be grabbed. No! Damn it! Damn it! I was trying to turn it around and it just slips from my tweezers and it flew away somewhere. Where did it go? Damn it. Where did it go? Okay, definitely using the box. Okay. So, this one goes there. And R155. And let's place these ones. So, no way. Okay, using the box. So placing them one by one where they should go. I got 152 and one beside it. One thing I find tricky is the fact that I can't really place my hand on the board to kind of get a better balance on the tweezers, so I can place exactly when the part is farther away, because there's solder paste everywhere. You can make parts a bit tricky to place. Okay, maybe, can I zoom this in? Let's see. So all of these resistors are 270. This plugin is definitely a big time saver. KiCad Interactive HTML bomb. Come on. Trying to rotate the resistors with tweezers. It's not the easiest thing in the world. How to make a 402 resistor jump. Place it on the mouse pad and just pinch the mouse pad with the tweezers, and it just goes flying. Okay, come on. One of the benefits of using solder paste is that you don't actually need a microscope to place the components properly, even if it's tiny components, because you don't have to place them properly. You just need to place them close enough so that the reflow can take care of the rest. find that just getting a little bit of solder paste on the tips of the tweezers can make it a little bit harder to place components because they stick to the tweezers. When they fall, they just turn around and I have to flip them. It's not the easiest thing in the world to flip small components. But this is going quickly enough. So, one board done, and now I'm gonna go to the next board and place the same components on the next board. Let's see. So placing the components on the next board. I've always thought that soldering surface mount components is actually easier than through-hole components. Once you start working with surface mount components, you just want to go smaller and smaller because you figure out just how beautiful it is to reflow them instead of having to solder each pad with a soldering iron. Biggest disadvantage of the surface mount components, especially the small ones, is that if they fly away because of a little bit of wind or whatever, they're very difficult to find. Imagine I were to sneeze right now. That would be a disaster. Come on, little resistor. Move into place. There we go. Turned around, so I had to flip it. Next one. There we go. Okay, that one's done. Next board, the same thing. So I have 3 boards that I'm assembling right now. So I have components for 3 boards. This is 3 prototypes of my motor control board that I've developed, which you can see. You can actually watch the full process of developing this board, from the block diagram to the PCBs. through the layout and the reviews and everything. So have a look at the KiCad PCB design playlist. And every video is streamed live. So some videos, sometimes I'm really unhappy with some of the videos because they just turn to shit and nothing works. That's kind of part of life. Nothing ever works all of the time. There's no point in me pre-recording videos and then clipping out all the bad parts. That's just not gonna happen. I may clip out the boring parts. Like if nothing is happening for an hour, that'll be pretty boring. I think most of the parts of the videos are useful in some way because they depict the raw experience. What the fuck? Where did it go? The raw experience of creating a PCB from scratch in KiCad and getting it manufactured and having to deal with bullshit brought to us by the small resistors that don't want to behave properly. Okay, there we go. Yeah, let's see if I can move this a little bit. Shouldn't really be necessary to have this many resistors on the SPI lines, but I didn't want to change the design. I think this particular design, since it's a prototype, it's allowed to be expensive. It's not so much about minimizing costs at this stage. It's more about putting as many features on the PCB as possible so that all of them can be tested, and then once everything is tested, then we can optimize. Then we can just delete parts of the PCB, make it smaller. It's always it's disproportionately more expensive to add features to PCB than to remove them. So easy to delete stuff. So much harder to add stuff. Naturally, I don't want to. I'd rather delete things than add things later. No. There we go. Come on. Come on. Come on, little resistor. Flip round. There we go. I got so much solder paste on my tweezers now that all of these resistors are just sticking to my tweezers, which is kind of annoying. I need another pair of tweezers, or something that I could use to just... Oh, damn, this knife is dirty. Let's see, I'm gonna just dry my tweezers. You're just wondering which board is this. This is a board that I've developed live here on YouTube. So the full design process is documented live. From the block diagram to this stage. Let's see. So there is the resistor. Come on, little resistor. Hopefully this resistor will stay in place now. Yeah, great. So now that my tweezers were a bit drier, the resistor actually stayed in place and not followed with my tweezers. But now there's a total mess here. Oh, come on. So a bunch of resistors close together, and the solder paste is drying up, so they kind of move around and follow each other. I'm going to leave them like that for now, and hopefully reflow will fix that. Okay, so next would be, let's see, next would be, I mounted these and, oh, damn it. Next I have a few resistors here. R74, 75, and 73. Hopefully I have enough resistors. I think I have lost one resistor. So far. Okay. Don't be surprised, Chris, that it's so quiet. It's the middle of the night. so it's, I guess everybody's sleeping. Let's see. Next resistor is R74. So this is all part of the encoder interface. It's the resistors that surround the encoder interface chip. And after looking at the cost of the chip, I kind of started thinking that maybe that chip is way too expensive for continued use. Oh, I found a resistor. Is that the resistor? I wonder which resistor this is. I have to test it. This must have been a resistor that flew away earlier. Okay, so I'm just gonna test the resistor that I found, and it's 270 ohms, which means that I have all the resistors I need, I think. So, nice to have this resistor back. R75, R73, and R74 on this board. And 3 more resistors left. I think actually, no, I got a few more. Probably the other ones go on the back of the board. I'm going to place the components first on the front of the board, and after that I'll reflow them, and then I'll do the back of the board. Alright, I'm going to check if there are any of these resistors on the back. Let's see. Yeah, there are a few. Okay. Go to the front, and I'm going to put back the resistors into the baggie. And I'll leave them for later. Okay, putting them back into the bag is not the easiest thing in the world, because they tend to stick to the box. They're so light. I wonder if I will even find them when I need to take them out again, because they're so small. This is why it's probably a good idea to place everything on the top layer and no components on the bottom layer. Anyway, moving on. Next is RS422 encoder interface. Now, does plus mean pin number 1? Yeah, I think so. Okay, this is a QFN package, small QFN package, but that's no problem. I just place it on the solder paste. Right, this one is not going to be, the third board was a bit messed up actually, and the ground pad is messed up as well on all of them. It has solder mask on it. Fortunately, there are vias that are exposed, so at least the pad will connect to the vias and then to the ground. This really needs to be fixed. Okay. Oh, damn it. This is something I have to double check, because then I'll have to actually apply solder paste on the vias, because they were not on the stencil. Okay. Let's double check. So first of all, I'm going to fix the main issue here. The issue is on this chip here. Let's see. So there is no mask on this pad, so we have to edit this footprint. Right, okay, cool. So there is a pad here, the smaller one, and this one should have the mask layer, just the front mask layer, and these ones need to have the paste layer. Cool. Okay, so this one is fixed, and let's see. Next, I want to check the data sheet of this chip. Let's see if it makes any difference. Let's see. the question is if the ground pad actually needs to be connected or can be left disconnected. What the fuck? This is, by the way, the new KiCad. The grid is more visible, I guess. They made it less transparent. Anyway, properties, library editor. Actually, I can do like this. So now I don't have any custom changes applied. To this version of KiCad. Let's see, ground pad. Exposed pad, connect EP to ground. Not intended as the primary ground connection. Okay, so then it doesn't really matter. It's good if it's connected, but it doesn't really matter. So for the prototypes, it's probably fine. All right. Going back to video here. Let's see, where's the video? There. Oh, let's see. Right, this was not the correct one. Maybe I can click here. Cool. I can. Ah, I see. This one. Yeah. So that one's placed. Just place two of the remaining chips. And moving to the next one. Next is some connectors. They'll go into the box, save for later. Next is resistors, 402, 137K. Where are they? There. Okay, 40, 48. Only 2 of them on the top layer. The rest is going on the bottom layer. So I'm just gonna open 6 resistors. And put the rest in the back. R40 and R48. I have a feeling that this solder paste is actually oxidizing because it's getting darker with time. Probably cannot see where I'm placing this resistor, so it really doesn't matter. It's only 2 of them. Let's see. Now it's stuck on my tweezers. There we go. Okay, and next is 470 ohms, which I think is for the LED. How many? Yeah, a few more than just for the LED, so probably use somewhere else as well. But on this layer, just for the LED. So I'm just going to unpack and place 3 of them in total. And the rest is going in the bag. Let's see. So the LED is over there. It's going to be really interesting to see the comparison between factory-made board by PCBWay and this board that I assembled manual. No, damn it! Happened to move my first part. the switch. Okay. Resistor placed. Next. Oh, it's time to place the STM32. Interesting. This is going to be pretty quick. So the STM32s come in nice boxes like this. And the box comes in the back. Let's see. Unboxing STM32. Woo. Okay. So these ones go. Let's see, where's pin 1 though? Right. Pin 1 is over there. So the marker will go over there. There are actually 2 markers on the STM32 chip. One is a bigger one and the other one is a smaller one. That's the smaller one that counts. Okay. Let's see. Just drop it in place and move it towards where it should be. Like that. Gotta make sure that it's properly aligned because otherwise it can solder on wrong. Reflow can take care of some issues, but not all of them. Well, this is sitting pretty nicely. Very nice. Next one. And the last one. Oh, the last one needs a bit of assistance though, because there is no solder paste on some pins. Okay, what I'm going to do is move the chip first. I'm going to place the chip on pads, and then I'm going to add some solder paste to the pins that don't have any. This will probably require some fixing afterwards. Actually, I'm gonna just solder them manually after the fact. After I've done the reflow. So that's it. STM32 placed. And that's pretty much what this placement is all about. Just taking the components out of the bag and placing them on the solder paste. And I think overall it's a pretty boring process, but I do find some faults, such as, for example, discovering that ground pad didn't have any solder paste, and it didn't have any mask opening. So it's kind of it's useful as well. It's kind of like a second stage review, final review of the design. Although not the final review, because the final review is actually testing that everything works. But nonetheless, I found it useful to assemble a few boards manually. I'm going to stop the video and I'm going to continue placing all the components, and we'll see how long it takes, and then I'm going to be reflowing the boards. Thanks for watching. Bye.